Creating complex 3D models is all about creating elements and modifying them. Modification of existing elements starts by first selecting them and then doing something with them. So the way to modify any model has two fundamental steps. Number 1. Select the elements. Number 2. Do something with the selected elements. This might seem trivial, but being able to select exactly the elements you want in a complex model can be extremely tricky and time-consuming. Most programs handle selection issues by using selection filters. COMOSYS 2 has extremely powerful selection filters, which will be explained in another video, but they are very detailed as can be seen. While they are absolutely essential, it cannot be denied that setting up a filter to get the results you want will take quite a few clicks. Since selection is at the heart of almost everything, we have developed on-the-fly filters, which are extremely fast and serve the user well for the most common filtering requirements. This on-the-fly filtering for selecting only a certain type of object is triggered by simply doing a window selection and pressing Enter. If more than one type of objects are selected, COMOSYS will group the selection into subtypes in this dialog box. As you can see, the frames, plates, bolts, welds, cuts, rebars, and even macros, etc., have all been grouped here on the left. So let's say you only intended to select the bolts. You just click this bolt button, and a second level of filtering options will be created in the pane on the right side of this window. As you can see, while if we wanted, we could simply click the topmost line on the right pane to select all the bolts. We have been given the opportunity to fine-tune our selection by selecting bolts of any particular diameter, if we wanted to. And that's not all. On the bottom side of the right pane, you have further options. As you can see, you can select other bolt properties like material, assembly, and length. The grouping is recalculated depending on which check boxes have been ticked here. This type of on-the-fly filtering is extremely powerful and time-saving. Once you have the desired grouping, simply double-click on the group line, and the initial random window selection will be filtered to give only the results you are interested in. Once the desired objects have been selected, the dialog box of that object type opens, and you can make whatever changes you want. It should be mentioned here that the dialog box will show all parameters as empty except those which are common across all the selected objects. When you change one or two parameters in the dialog box and press OK, only those parameters will be changed for all selected objects and the rest will remain untouched. This is exactly what you want. The same grouping is available for frames, plates, welds, rebars, cuts, and other objects. Each object type will have its own most frequently used grouping options in the window pane on the right. The frames, for instance, can be grouped by profile name, beam group, material, etc. Welds will be grouped by size and weld types. Plates will be grouped by thickness, material, etc. Rebars will be grouped by diameter and other parameters. But perhaps the most useful is the grouping of macros. As you can see in the right pane, the selected macros have been grouped by macro type by default. There is no other grouping at this level. However, once you double-click on a particular macro type, a third window opens, which allows the user to further subgroup that particular macro. This subgrouping is extremely useful, and this kind of filtering is not available in most commercial programs. As you can see, the macro type selected has been subgrouped according to its main and secondary members. So for instance, if you choose the stiffened end plate macro, all instances of occurrence will be grouped by COMOSYS according to groups, in which the main and secondary frames are the same profile. And that's not all. At the bottom you can see a further grouping option by approach angle. This is even more revolutionary, and make the job of modifying the model extremely easy. Here the stiffened end plate macro instances are further subgrouped according to the approach angle of the secondary profiles. So all instances where the secondary is approaching from an angle of 90 degrees will be grouped together, whereas those approaching from other angles will be grouped in their own angle ranges. This angle range is customizable but 5 degrees by default. So all instances where the approach angle of the secondary is, say, between 40 and 45 degrees will appear as one group line. This is tremendously helpful, as most of the times, the user wants to only modify certain instances of a macro and not all macros in the model. So if you wanted to change the end plate thickness, or some other parameters in all stiffened end plate macros, where the main frame was HEA 300, and the secondary was IPE 300, and the secondary was not inclined to the main, but perpendicular to it, you would simply find this particular subgroup and double-click it. The dialog box for only those instances of the macro would open. And now you can simply change the thickness of the end plate, or some other parameters as you want it, and press enter. The more you use it, the more you will realize how much time on the fly filtering saves you. It's not that these things are impossible to do in other programs. It's just the number of clicks it takes to do them. Doing the same thing with 6 clicks as opposed to 3 means finishing the job in 2 months rather than 1.